Hello, everyone. Thank you all for joining me today. I'm Judy Piper. I'm one of the engineering leads at cLabs and also the host for this Tech Talk series, one of the many Celo Foundation's efforts to share and spread the Celo technology knowledge with the Celo community. Since April this year, we've been providing this series of educational sessions about Celo platform so that anyone can learn the technical ins and outs of a Celo network to support Celo's mission of building an inclusive financial system. For this reason, we strive to make the content accessible and inclusive to anyone who wants to learn about Celo technologies, from mobile application to distributed systems to blockchain to cryptography to infrastructure. For those who missed this previous Tech Talks, we have recordings available on Celo Foundation's YouTube channel, and I'll be sending out a follow-up email after this talk with the links to help you learn more about Celo and how you can get involved. You will also find a link to the feedback survey form. We very much appreciate your feedback and would like to hear from you with the suggestions and great ideas so that we can continue to improve the content and keep them relevant to this learning community. For today's Tech Talks, I'm really excited to have Connor join me to talk about Valora. Celo has always been a mobile-first full-stack solution, and at cLabs, we've been working on Celo with the end users and community. And Connor, who is application engineering lead at cLabs, has been working on this full-stack solution as one of the first employees, but also he has been focusing on building the mobile-first, therefore end-user-first application that is Valora. So welcome, Connor, and thanks for being here. And before we start the talk, could you please share your Celo story and your background a little bit and how you got involved in working on Celo?
Sure. Yeah, thanks so much, Judy. I'm really excited to talk today, and thanks for hosting. So yeah, as Judy mentioned, I joined cLabs as the second employee almost 2.5 years ago now, and I think there's a couple things that got me really excited about building Celo and now Valora. I think one was just a desire for more international impact in my work. I think I'd spent like a while traveling in Latin America and kind of, just seeing WhatsApp everywhere and having like a mobile background myself. I kind of just had like this idea that, hey, like I should build something that, I could imagine everyone using. I think like WhatsApp kind of has that kind of global reach. And I think that that was like certainly in my mind. And then also just kind of seeing the potential of blockchain as like, following the space for a while. I tried to mine Bitcoin in 2011 and my university shut off my internet access after a couple hours. So it was something that I'd like followed for a while, but just kind of seemed like the perfect time to kind of take that, interest in international impact and also kind of the development of the blockchain space and build like a really compelling.
Wait a minute, product. You used the university server to mine?
it was my computer. It was just the network.
Oh, okay.
Yeah, no. It was like my, but and it did last very long, anyways. But yeah, so since then, I've really been focused on building Valora and also kind of leading the team working on Valora. So it's super exciting to just have a chance to talk about it a little bit, and then also show you something that's going to be launching very soon.
Awesome. Let's get started.
Cool. And also just to note that please like feel free as I'm talking to like kind of in the chat if you have any questions or you want to ask a question. I'm like usually a pretty good multitasker, so feel free to kind of ask questions as we go along. Yeah, so let's get started. So just to give you a little idea of the agenda, first we're going to talk a little bit about like how we design the Celo protocol with mobile in mind. I think that's like a really important piece to understand like how we were able to build this. The second thing, we're going to talk about Valora itself and some of the features and functionality you can find. I'll talk a little bit deeper about the architecture and how it kind of works on a technical level, and then also share some of the like blockchain challenges that we faced working on mobile. Yeah, so first to start with Celo, for folks who may not be familiar, our mission is to build a financial system that creates the conditions for prosperity for everyone. And the way that we do that is through this kind of Celo platform. It's kind of a very full stack approach, just because we believe it's necessary to like kind of have an end user product in order to really provide the reach of the network. So we have kind of the application layer, which has been my focus, and where Valora lives. We have the core contracts, and then we have, which are written in Solidity, and then we have the blockchain itself, which is a fork of Go Ethereum, and that's what actually runs the network. And so kind of the contracts and the blockchain comprise the Celo protocol. And what, from day one, we kind of had this idea of how can we design the Celo protocol for mobile. And part of what really informed that has been a lot of user research and kind of talking to folks that, as early as we could, we tried to build something that we could show off to people, kind of, just meet folks where we thought this might be needed most, and then also understand kind of like the shortcomings, what's confusing, and like how to kind of shape the direction of the protocol so that we could truly meet the needs of the people we're hoping to serve. And so kind of throughout that process, some starting very early with the white paper, and some kind of, throughout this user research process, we kind of reached a couple mobile specific protocol features. I think the first and the early idea of Celo was having stable value currencies. And we just felt that price volatility was a huge blocker for average people to use cryptocurrencies. I think, when you're looking for day-to-day payments, you kind of just want to like pay someone back for the piece of pizza, as opposed to give them something that might be worth 2x what it was yesterday, or half that. So that's like one kind of thing that we think is really valuable for this kind of mobile use case. We also have gas payable in multiple currencies. I think one of the things that directly came out of some of these user research trips is just like, hey, what is the Celo dollar? What is the Celo native asset? Like, why do I have to have this other thing to pay to transfer like Celo dollars? Like, I think there's already a question of like, what really are transaction fees? And so having to have another currency to pay for transaction fees, I think was like really confusing to end users. I think another piece was just kind of identity, and especially in mobile, there's like a couple things that we might use for identity, but I think the biggest one is just phone numbers. And part of this kind of usability and access thing that we think was important is like when you are trying to pay someone, you need a way to like find them, and copying and pasting a long hex string is not a super user-friendly way to like find someone you're trying to send money to. And so that's kind of what led to this like identity protocol, and I'll dive in a little deeper there. And then kind of the last thing, and I think was like a really cool technical achievement when you dive deeply into it. And I think Michael Straka gave a talk a little bit about this, but just syncing quickly for Ultralight clients, that part of the way the protocol is designed is so that like a mobile client can actually get the latest chain data and sync to the latest header without requiring any kind of like centralized trust, right? That like by having this chain of headers, that we're able to kind of prove that we have the latest data, but we're not relying on kind of a centralized authority, which makes it like much more censorship resistant and like truly decentralized. So yeah, that kind of fast sync and ability to like get the state of the network in decentralized way, I think is really amazing. So yeah, this first thing, CUSD, for folks who might not have seen, is a stable value currency pegged to the US dollar. And like I mentioned, that's kind of motivated by a desire to provide certainty in the value of your currency. There's another great talk which happened just diving a little bit deeper in stability mechanism, but kind of at a high level. There's an on-chain reserve of Celo and other crypto assets. We have a set of oracles that will report the price of Celo to USD from exchanges on chain. And then the stability mechanism, and this we have an automated market maker exchange function we call CP Dodo, and that kind of enables folks to kind of on chain swap between CUSD and Celo, and that's kind of a piece of the stability mechanism as well. This kind of piece around enabling users to pay for gas in a stable currency, like I mentioned, just some of the feedback we heard from people is, cryptocurrency is confusing, blockchains are confusing, like having two separate currencies is kind of confusing, and then having to like pay to transfer one is hard to understand. And so what we kind of built into, yeah, as I mentioned, how do I pay for transactions? Like, where's that money going? And what is Celo, this other asset? And so what we added is this fee currency, and this is part of kind of the celo-blockchain client and these core contracts, is that the ability to kind of pay transaction fees, which are eventually going to validators in a different currency other than the Celo native asset. Another piece, as I mentioned, is kind of the identity protocol, and we felt that from a usability perspective, just being able to find people that you want to send money to is really important. I think a lot of folks have a mental model of like looking in their address book for people, usernames. There's like some way to find who you want to interact with, and so that's where we have the kind of lightweight identity protocol. And how that works is, end user requests an attestation. We have an attestations contract if you want to dive in a little bit deeper there. But basically, like in onboarding to the network, user requests an attestation, which is a smart contract call. There's some randomly selected validators, which the user is paired with. They reveal the phone number that they wish to receive a message at to the validators attestation service, and this is kind of another service that validators run. They'll receive a signed attestation via text message, and then that basically they'll send another transaction that kind of proves, hey, I received a message signed from this validator at this phone number, and they do that a couple times, and that's kind of how we prove that basically this person has access to this phone number, and that's how we kind of map their phone number to address. One of the things we heard again from users and ourselves was kind of like, how can we ensure that phone numbers remain private? Obviously, blockchains are immutable, and so once something's on there, you kind of can't take it off. And so we wanted kind of this to balance this like desire for usability while also kind of respecting people's privacy. And that led to this pretty cool thing. We have a name now called Otis, the Oblivious Decentralized Identifier Service. And basically that just uses some cool actual cryptography to generate a unique pepper per phone number. And that's kind of just like some unique string that the user is able to find and then use that to like hash with the phone number such that it's discoverable. Like, people who want to find if this user is on the network are able to kind of query and find that, but you're not able to scrape the whole set of phone numbers from the network. So I think this is like a pretty cool piece of technology that enables this, like I mentioned, kind of end user experience. And the way that works is just by like as a someone trying to look up another person's phone number, you'll kind of sign a message and kind of hide basically the number that you're trying to request. There's kind of this set of folks running Otis, and it's engineered in a way such that no runner of the service or end user can kind of like reveal the entire set of peppers per phone numbers, but each user is able to be like kind of rate limited and able to query it. So the last bit, just that on kind of the protocol design, which I mentioned, is this Ultralight client, and that enables like real fast syncing on mobile devices. And we have some cool things in the pipeline around snarks, which will make this very, very fast. But I think, as I mentioned, we believe it's important to kind of provide access in a true decentralized, trustless way to the blockchain and the network on a mobile device. And so what this kind of Ultralight client sync enables is just syncing epoch headers. For folks who didn't watch Tim's talk on proof of stake, there's basically every 30,000 blocks, there's a new epoch, and that's where there's potential to change the validator set. And by only syncing headers from each epoch, you're able to have to fetch much less data from the chain, but you're still able to verify from the beginning of the Genesis block to the current state. And part of the reason, like I mentioned, that we wanted to do this Ultralight sync is that we wanted a truly global blockchain. And I think that, again, kind of some learnings from trips is people might have intermittent data, so you can't always be online. You might have difficulty charging even, and so you're not having consistent phone always running online. You might need to go somewhere to charge it. People running older devices, like we target API 16 on Android, which is Android 4.4. And that's just because like a lot of folks don't have the latest Android APIs. And so I think that to make, to create the conditions for prosperity for everyone, we need to be like understanding of where folks are at in terms of their hardware. And then I think also just kind of folks might have lesser technical fluency. And so that's kind of where Valora, I think, especially comes in, is that there's a lot of complexity as you're seeing. And I haven't even touched on a lot of it, but I think that you shouldn't have to understand how a blockchain works in order to use it and get value out of it. And as I mentioned, this kind of like Ultralight sync here is a little bit more on how that works. But basically you can see there's like the network of validators. There's a bunch of full nodes who are syncing the full chain state, and then light clients are served by the full nodes. And so that's kind of where they fetch the headers from. And they also fetch some chain state through a Merkle tree. And that's kind of what enables this kind of Ultralight fast sync. So now, hopefully getting to the part where people are here for is to actually introduce the Valora wallet itself and show you a couple of the features. At the very beginning of the Tech Talk series, Jean did a kind of demo of the Celo wallet. And so if you want to see a live demo, I definitely recommend that. But I think I'm mostly just going to focus on some of the features in the architecture because we're already kind of onboarding folks from the community. And I think by joining our waitlist, you will be able to play with it yourself very soon. So I don't want to ruin that for you. Yeah, if you want to join the waitlist, you can see it at valoraapp.com. And yeah, I'm excited to, we've already been getting a bunch of great feedback from people and really excited to get more. I think at the end of the day, like that's why I'm here, is to build something and kind of get it out there and hope people use it. So I think the kind of most key piece of Valora is sending CUSD. That's kind of what we designed from the very beginning of just like a core use case. It should be as fast and easy as possible to send celo dollars anywhere in the world. And what's really cool about kind of the underlying architecture is that the finalization of transactions is much, much faster. Since we're not mining, it's a proof of stake network. So you can kind of get that feedback of like, hey, your transaction is added to the chain and finalized very quickly. And I think like when you see it and use it, especially compared to sending other cryptocurrencies, it's pretty awesome. We also, as you might see from the screenshot, kind of support local currencies. And so even though the underlying asset that people are sending around is a celo dollar, and we've kind of designed the protocol to support other stable assets eventually, folks are used to doing kind of like business and payments in their kind of local currency, right? If you go to a grocery store, like they're going to have the prices denominated in whatever your local currency is, and not necessarily dollars. And so kind of to enable folks around the world to use Valora, we have the ability to kind of select the local currency. And so you'll see celo dollars, whatever the current exchange rate is between the celo dollar and your local currency, you'll kind of be able to like send and see payments with your local currency. Part of what we felt like too is really important in the product is like the onboarding flow. I think that's a place for anyone who's done mobile development, is where you can like lose a lot of folks as if it's confusing, they don't see the value of the app, or they kind of get, especially like social networks, if you kind of get somewhere and like it's a ghost town and you can't do anything yet because no one else is there, it's I think pretty frustrating. And so we wanted to kind of create this onboarding flow that enabled new users to have a really great experience. And so part of how we did that is by creating this like invite code. So what that is just a private key with a small amount of money on it. So when you invite someone, they get an invite with like just on the cent scale of celo dollars, and so they can use that to send transactions and get started right away. What they'll likely use that invite code for is getting verified. As I mentioned, we think a really important piece of the end user experience is be able to discover people, and so kind of map your phone number to an address. And so that's what folks use that first invite code for, is to get verified. So you kind of, as I mentioned, call the attestations contract. You'll pay the verification fee to that contract. Although we are kind of working on ways that people might be able to verify without paying that attestation fee. And you'll then get a couple text messages, kind of verify your phone number, and then your people are able to discover you. What's even cooler about this verification flow is that you can actually escrow money to people. So like for myself, I was like, I don't know how early, but I was definitely a Venmo advocate to my friends. Like when Venmo came out, I was just like, hey, we should all use this. Like when we got to split the bill somewhere, like, so I would kind of use it pretty frequently, where I was like, hey, you put your credit card down and I will like Venmo you some money. And then you'll sign up for Venmo and collect it, right? And I think that with existing blockchains and kind of this address structure, it's like not really possible to do that, right? Like if someone doesn't have an address, like how do you send them money? Okay, you could generate an address and send it to them, but then you're the person generating the address, so you have the private key and you need to give them the private key. I think it's kind of this like confusing, especially and like risky if there's like a lot of money for something, right? If you pay someone $50, you don't really want to like just text them like a private key with $50 on it. So this escrow functionality is really cool in that you can kind of escrow money to a specific phone number. And then once someone has kind of verified that phone number, they can collect that escrowed funds. And so I think that kind of provides this new user, hey, like you don't have to sign up in order to get money, which we think is like really awesome, but you can still, make sure you're like, as the person sending, you can make sure your funds are safe. Another thing that is important for us is we, want Valora to be non-custodial. There are a lot of wallets where some centralized service holds access to your keys. And I think that, in conversations in the team, like we aren't opposed to the idea of centralized services, like especially for, some of the folks in the community building like on USSD or like kind of like feature phone technologies. Like there are some limitations where having a centralized service holding keys for you might be necessary for someone who just wants to get access to the network at all. But I think for us, it's like really important to, give people that choice of whether they prefer to custody or, eventually they might want someone else to do it for that. And so, from day one, Valora is non-custodial, which means like only users have access to their funds. We just think from a security perspective, it's much more secure and kind of embodies like a lot of the ethos of cryptocurrencies and blockchains is having people custody their own funds. We also have this data saver mode. So even though we've designed the protocol to be as lightweight as possible, and like we've designed people to be able to run full like clients on devices, there are still, I think, situations that we found in the field where even like the latency is just really slow on whatever network you're using, or you're like really data constrained, and that's where we have kind of this data saver mode, which enables folks to just use a hosted full node to kind of relay transactions for them. Obviously, you're still keeping your key on your phone and signing transactions there, but you're kind of depending on a full node to like relay those transactions to the network and kind of serve you. And so I think that, like I said, kind of with the key storages that we've designed in a way that is fully decentralized, uses a light client, but I think we also want to meet people where they are, and some of the some people are in places where just like data access and latency is really bad, and so we still want them to be able to use Valora. And then kind of another last bit, which I think is a pretty cool feature, is the ability just to use the on-chain CP-Dodo exchange to swap between CUSD and Celo. Folks who might want to participate in the stability protocol, either through arbitraging or staking, is something that's a key piece of a proof of stake network, and it's not something we support at launch, but I think there's certainly an idea that having the ability to stake Celo is something we'd like to offer the community. But I think that just to be able to send and exchange between CUSD and Celo has been important, and that's actually something too that some of our early testing folks were getting some Celo on an exchange and sending it to Valora and kind of wanting to like be able to send it or potentially take it out, and so that's something too we added as a very recent feature, is the ability just to like send Celo as well. And then the last piece, which I think is relevant here for any developers or any folks interested in building on top of the network and Valora, is DAppKit, and that's our kind of like DApp functionality. And so this is a little bit of an older GIF, but you can see that Nom saving circle is a DApp. I love the idea of saving circles. I think it's super cool. And by having this UI and then kind of kicking out to the Valora app through a deep link to sign and relay a transaction, dApps can provide a really nice mobile flow that we think will enable a lot of like true native mobile dApps, as opposed to things that you might have to use a dApp browser for, or other like Chrome extensions. I think it's just with our mobile focus, we think that providing a nice dApp experience will enable people to build some really cool things. All right, so hopefully that got you a little excited about the Valora features and getting an access. And as I mentioned, we're onboarding folks, and so excited for you all to give it a spin. But the next thing I wanted to talk about is a little bit deeper into the Valora architecture and how we built it. So there's a couple kind of like layers here, and I think that's part of why it's so difficult to build this application. It's certainly like the hardest thing that I think I've worked on from a mobile perspective, and that's because like, yeah, it's just a very full stack. So kind of at the bottom is the celo-blockchain itself. So we actually compile and run the same celo-blockchain code that's running on validators, that's running on full nodes. It's a pretty cool tool called Go Mobile, which enables that. But yeah, we're running the same same code that's running on servers. Kind of the middle layer and is ContractKit, and so that's the SDK to easily work with the protocol contracts. As consumers of a lot of the contracts, I think there's in making a lot of contract calls that we basically just wanted an easy, abstracted way to make it as simple as possible, just to kind of work with the core protocol contracts. And so that's that SDK. And then kind of at the top, and then more user facing, is React Native. So the app is React Native, and that I think enables like a great like UI. I love the kind of React component model, and yeah, it's all written in TypeScript. So yeah, so kind of diving a little bit deeper into the celo-blockchain, is that so we actually use as I mentioned, celo-blockchain is a fork of Go Ethereum, and so it's written in Go, and Android and iOS devices. Typically, you write Objective-C or Swift, or you might write Java or Kotlin for Android. But what's I think pretty cool is you can actually compile this code and kind of import it as a library, and that means you're running the same code, but using the same JSON RPC commands and everything that you're familiar with if you're actually running a celo-blockchain node, but you're doing it on a mobile device. So just from like a developer perspective, and yeah, it's like the same diagram kind of provides access to talking to full nodes, talking to the network. From developer perspective, there's like I think a couple of reasons why this is great. One, it's cross-platform. You can imagine a world in which we wrote like a light client for each platform in their kind of like native language. Like we could have written a light client in Java, we could have written a light client in Objective-C, but I think that would take a ton of time, and it's really hard to kind of keep everything at parity. As folks who are familiar with the parity Ethereum client might know, it's just difficult to kind of like have different implementations and kind of make sure that you kind of keep them in sync. And so that's why I think that compiling enables us just to kind of keep all of our code up to date. It also leverages existing tools. So I think you'll see that a lot of places is that I think as a team, I think we're like pragmatic in the sense that our end goal is to like deliver value to people, right? It's to make something that is useful to people. And so I think that I certainly have opinions about like what the best programming language is and how, like kind of can do nitpicky things. But at the end of the day, like we should leverage as much as possible the existing things that will enable us to build what we want to build. And so I think that's where this kind of also factors in. And then I think the last piece is just kind of like sharing features across validators, full nodes, and light clients. I think something that we haven't really spent as much time on, but I think is pretty cool and enabled by such a focus on light clients is kind of, using light clients in more common tools that you might see like cLIs or kind of like a web UI, right? Like right now, almost all kind of like web dApps will use some centralized service to kind of like serve their data. And that's just because it's like, the idea that you could like run a full node quickly and have like quick access to chain state is not really feasible. But I think that you can imagine a world in which like, yeah, you just like every so often, like you just might have a background like client running and you can kind of configure websites to actually talk to that. And kind of talk to like some local data serving. And so I think that kind of promotes more decentralization of the network, and also is just I think potentially might provide you a better experience if you don't have to, depending on where these hosted services are geographically distributed and any of the load or latency that they might face. I think that this kind of like Ultralight client for just doing local things like CLI or web development is will be pretty useful. So the next piece, kind of like the mid layer, as I talked about, is contract kit. And so that is really, I don't know if people are familiar with the Solidity logo. That's it right there. But that's basically our interface to the core contracts. It kind of uses the Solidity contracts and TypeScript to generate like nice wrappers and kind of an interface to the contracts. So for example, that escrow contract that I mentioned, that enables this kind of nice escrow flow in the app. So this is the Solidity contract or I just function. So, you have some function of transferring and kind of like, once you've verified, being able to kind of pull funds out. And so this is what the Solidity looks like. And then what we've built in Contract Kit is just the ability to kind of wrap that contract and then use it. And so this is some code from the mobile client itself, and that you can see it just grabs the escrow contract, can call functions on that, and I think just abstracts a lot of, and also provides type safety. I think we're big fans of TypeScript just for that type safety, and I think there's a cool tool called TypeChain, which just kind of provides types for those functions, and so I think just enables us to move quickly in consuming contracts. Yeah, as I mentioned, I think Contract Kit is useful. It's a common interface to the celo contracts, which hopefully is useful to all developers. Again, it just like leverages existing tools. So we use Web3 right now. I think there's definitely a desire to reduce the bundle size there by exploring other tools. But again, just the fact that we can kind of build on top of libraries that are already kind of commonly used, I think enables us to do more. Type safety, I think that's a big benefit, especially like as our team has grown, working in a larger code base. The monorepo, if folks have looked at, is pretty big, and so kind of making sure that not only do you provide good documentation, but your tools might stop you from making mistakes, I think is a real benefit. And then the last piece I think is also just kind of by the nature of having such a full stack team of folks working on the protocol and folks working on Valora that we're really like dog fooding our developer tools, and that we're getting a good idea of like, hey, okay, we had an idea that this might be easy to use, but when we look at it in practice, like here's the issues that we're running into as application developers. And I think that kind of like feedback loop is really valuable to like folks on the protocol side, folks working on the SDK, and you know, as consumers of these tools, the application developers too. The last piece, kind of in the stack, and is a big piece is React Native. So I'm certainly a little biased. I've been using React Native basically since it came out. I got on the early beta in a Dropbox folder from someone somewhere. But I think as someone coming from like native mobile before, but also web, that it provides just a great tool to build mobile applications. And I think part of that is that it's cross-platform. So we ship both Android and iOS apps. We started Android first, just because I think, as I mentioned, we have that kind of global focus, and wanted to make sure that, you know, whatever we did, that we would kind of make sure that it could work on Android first. I think, you know, as a developer, I think Android's just a little harder. Like there's like more rough edges. And so I think that, you know, making sure that we could build a good app on Android meant that we could, you know, shift that to iOS and kind of make sure it would work well there too. Yeah, React Native just allows you to leverage a lot of existing tools too, and especially in the context of blockchain and a lot of the community having like JavaScript and TypeScript. The fact that we could just plug in ContractKit, plug in a lot of libraries that folks were using elsewhere meant that, again, we could ship more quickly as opposed to having to like write kind of platform specific like libraries to interact with the contracts, or platform specific tools to talk to the node. So yeah, I think we really benefit from that. As I mentioned, I'm a huge fan of just like the component UI model. I think that the way that your user interface can just be a reflection of the current state. You know, you just have some data, and your UI is always just a reflection of what that current data is, as opposed to like you having to figure out how to like mutate it to change the UI. I think just like, you know, of course, everyone still has bugs in their UI, but I think that it's just easier to have fewer when you don't have to worry about how to mutate. And then I also think that kind of shared knowledge across the team is really important, that by using, like, I'm a big believer in just like trying to use the same tools as much as possible. And the fact that our apps are in TypeScript, and folks who work on the protocol also use TypeScript, means that we can have like just a lot more cross collaboration in terms of people reviewing PRs, like kind of like dropping in, like I think there's a nice like flow of like, hey, oh, if I needed to fix a thing in you know, a repository I don't work on a lot, I still feel comfortable doing that because we have this common interface of tools, and I think that's allowed our team to kind of move within the stack pretty easily. So yeah, I think there's a lot of fun things that have come with building Valora. However, there's a lot of challenges as well with kind of mobile blockchain. I think that part of those challenges are just because there's not too many people like doing this, right? I think that we like are, you know, just from like a technological perspective, it just like wasn't really feasible to have a light client running on your device unless you kind of made like, you know, build our protocol the way we did. And so it's fun and it's cool to be like, wow, we're really doing something that just hasn't happened before, but it also certainly leads to a lot of challenges as a developer. I think one is just there's a lot going on. So this is a little bit of like, not even a full kind of picture of like the application lifecycle, but just like getting started with the app. Like what's going on is, you know, you on the React Native level, you're like starting the app, you're like loading a bunch of JavaScript in the bundle, you're like rendering your UI, and then you kind of like kick off the blockchain side of things. And we actually use an IPC socket. So if folks have used Get at all, you might see know that you kind of talk to an IPC socket in order to communicate with a node. And so that's the same thing. The node starts on device, and you're actually just like sending commands using the socket. And so we actually had to write our own library and own wrapper to be able to kind of use like IPC and React Native. On the blockchain side, when you're starting the application, you're starting the cell-blockchain client that's like trying to peer with nodes on the network. So there's this idea of static nodes, which is like a pre-selected list of nodes that you would like to pair with and talk to, and that's just a list of IPs. But you're also able to use a discovery protocol with boot nodes to basically just like find and talk to any nodes on the network. And so, as the blockchain starts, it's kind of just looking for like, hey, who can I talk to, and who will give me data, and so that's kind of this discovery protocol. Once you pair with a couple nodes, then you need to sync the chain state, and so that's using this like Ultralight sync, and so you're kind of wherever you are in the database, like you might have saved, the last block you might have could be from yesterday, it could be from a week ago. Like there's no real guarantees about like on a mobile app how often someone might be using it. You can request some background processing, but there's no guarantees about like when and how you get that. And so you just have to be prepared that someone might not have opened the app in a month, and you need to have something that's responsive and gets to the current state quickly. And then that last piece of like, okay, cool, you have the latest header. Now you can actually like do things like balance and make smart contract calls or go through the verification flow. And so then once you have the like blockchain piece, running and happening, we also require some like Web 2 infrastructure. And this is like things like fetching the activity feed. So unfortunately right now, there's no easy way to get a list of all the transactions to and from your address. Blockchains are built to be able to like query blocks and like make smart contract calls, but not really oriented for scanning well. And so we actually use a great open source project called Block Scout to index the chain. And so it kind of indexes all of the transactions between any addresses, and then it stores it in a SQL database because SQL databases are good for querying things like this. And then actually we'll kind of fetch that with this blockchain API. And so that provides the activity feed. And I think philosophically, we've tried to make things as decentralized as possible, and kind of the core functionality in the sense that like you can send, you can receive money, you can check your balance, you can make smart contract calls like without ever talking to a centralized service. But for things with like the activity feed, unfortunately, it just like requires this centralized infrastructure right now. And so I think we'd love to work towards a world where that's not necessary. But obviously, as I mentioned, we're kind of in this world of building what we want, but also realizing that users have certain expectations of how things should work, and they should, as much as possible, we want to match their mental model. Another kind of like centralized piece is this push notifications. So if anyone's built push notifications, you have to talk to, there's like the Apple push notification service, and Google has like, Firebase cloud messaging or whatever, and it's basically just, you need to ping a server to say, hey, send a push notification to like device A. And so we have kind of a tool that runs in the background. It's just like watching chain state, and then also checking what addresses we have push tokens for. And so we're kind of looking for transactions that might be relevant for you, and then sending you pushes around them. And then another piece is that we have like a Valora specific feature of payment requests. So again, just, hey, you're out, and someone, you pay for something for someone. Hasn't really happened for me in COVID times for a while, but you might want to like request money from someone. And so this kind of, we have like just a database that will kind of store payment requests and provide, pop that in the UI for people to fulfill. So yeah, I think just part of the overall, I guess to say part of the challenges here is just that there's like a lot of different things happening here at like a lot of different layers. And so That's been certainly like a challenge. We've also just like run into some like difficult bugs. Like I've personally spent like a lot of time just like kind of like digging through everything to figure out what's going on. For a while, like on some random devices, we like just, this is probably one of the earliest things we faced was like the device wouldn't sync to the network. We're just like, hey, what's going on? Like, this is very like random. Specific devices that might happen more frequently. Depends where you are, and we kind of figured out through logging that that the clock was so out of sync with like network. So you have like your device has some internal clock, and a lot of the code is designed that like, hey, if if someone tries to send you a block from the future, like you should reject that block because like that's not possible, and someone might be trying to like do something malicious. But obviously, like if your clock is too far out of sync, you might think like a future block is like you're gonna ignore it, but it's actually just that you're way out of sync. So that was like certainly one that took us a while to figure out and kind of get working. So one I think particularly difficult one was like a EVM instruction on ARM64. So like a lot of folks running servers and full nodes and validators tend to run on the x86 architecture, and because we're running on mobile, it's Android. A lot of the Android devices are 32-bit, but there's been a big push, and now it's kind of required for anything you ship to the Play Store that you have 64-bit support. And so there's actually just like one specific contract call that was failing only on ARM 64-bit devices, and like in diving into it, there was just like, and I never actually figured out the cause of this, but there was one specific EVM instruction that like would behave differently on ARM64. So I had to just like rewrite the Go code for this EVM instruction to make sure that like it wouldn't fail. And it was basically just like changing the like logic, but changing the semantics, but keeping the same logic. Like the instruction does the same thing. I just had to like use 2 lines instead of 1, and that fixed it. Another one that Trevor just fixed, shout out Trevor, is like peering speed. So like mobile is, I think you're expected that you might get like your process might be killed a lot more quickly. Or just at random times, like you're doing some work and all of a sudden you get a shutdown signal and there's not really time to like gracefully shut down. And so part of that was when you're kind of like killed, you don't really have time to gracefully shut down and save stuff to disk. And so we weren't always keeping the list of peers synced. And so like when you would start up, it would take just a really long time to peer. Another one, x86 64-bit emulator, and it's like Android permissions. So for a while, like we just couldn't get it to work on 64-bit Android. I finally recently like spent some time figuring out what was going on there, and it just turns out that it was using some like syscalls that were the new Android permission model, like this like wouldn't allow you to do. And so again, just like as a mostly a factor of like not a lot of people trying to do this, not like the number of people trying to run Go using Go Mobile on 64-bit Android emulators, I think is like probably not that large. And so I think it was just a little bit of a factor of that. A couple other ones, Golang standard library, like we just had some issues again with like 64-bit devices and the standard library. And so just kind of had to update versions of that. We had some issues with like our light node gas currency, where some transactions weren't going through, and kind of some of the logic of checking whether you had enough funds to pay for both the transaction and the like transaction fee itself. We had to kind of fix, and then also I guess this wasn't really a bug, but it was like pretty difficult to get intent testing running reliably, but we now have that. We use a library called Detox, which is great. And so every time that we try to make any changes to the repository, there's like a full, on both iOS and Android, it kind of starts the app with the latest code, like tries to send a transaction, it kind of runs through a couple features. And so I think that was something that was like pretty difficult, but also now really happy we have. Overall, I just think, as I mentioned a couple times, we have a very full stack approach, and there's a lot of layers for things to go wrong in. And so as like kind of the end of the stack, we have, running Valora, we've kind of run into a lot of those issues. But I think that, it also is a unique position because we can then actually like go and fix those pretty quickly. Whereas, without having like such a close collaboration with our protocol team, like we just would be a little bit stuck and have workarounds. Cool. So that is all I have. Definitely check out valorapp.com, sign up for our waitlist, and yeah, excited to get you all on board.
Can we move on to the next slide?
Yes, we can,
Yes.
Judy.
Yeah, because I do want to make a quick announcement before we move on to the Q&A. So next week, I invited Anna to talk about her experiences doing the engineering and building Celo with the community and an end users. And she's going to share her experiences doing the user research and then engineering. So please come and join me with your questions you might have, how engineering in the field is like, and it's more conversation than presentation style that it had been in the Celo Tech Talks. So we're gonna have a good chat. So yes, join. Cool. Let's move on to the Q&A. We have one question posted by Jack. What is the difference between contract kit and dApp kit in terms of developer use cases? That's a good question.
Yeah, great. And while we're answering, I would love to, I don't know if special guest Corey is around, but we'd love to.
Oh, right. Let's bring Corey.
Corey, our designer's here just to kind of chat as well and answer some questions. But yeah, so, and what's the difference between contract kit and dApp kit? So contract kit is designed to kind of provide easy access to the core protocol and core contracts. So we use it at cLabs for like the Celo CLI. We use it for Valora. We use it for kind of like tracing transactions, like kind of just like any kind of anything you're trying to get access to contracts. So dApp kit is more used as a dApp developer where you want a user to sign a transaction or to send a transaction, right? So you might use contract kit to like make some contract calls, and then you might say, hey, I want like this user to send a transaction to this address or to do this thing. And so that's a way to kind of just tell Valora to send a transaction on your behalf. And so it's more about like you as a dApp developer not requiring access to private keys in order to like, have a user interact with things. And so that's kind of the divide, I guess.
Hey, Corey, welcome. You want to introduce yourself?
Hey, sure. Yeah, thanks for having me. Yeah, kind of just what Connor mentioned. I'm the designer. There's really two designers at cLabs. It's me and Taylor. I focus a lot on the product design stuff, on the product design side. So a lot of Valora is like, the vast majority of that.
I know, and design is beautiful. If I say so myself.
Yeah. Yeah, Corey, I'd love to, just get some like thoughts from you. I think obviously, like I talked a little bit about how there's some challenges that are unique to blockchain on the technical side. Like, what are some of the things that, for you working with us, that you found like particularly difficult or hard to kind of like work through on the design UX side?
I really think like the like most challenging part and also like the most interesting part is like just this, the complicated nature of blockchain and of cryptocurrency generally, and then like trying to basically control that in some way to like build like, a simpler model or really more just like a specific model. I think the like challenge of taking something complicated and making it simple is just like a generic to design, but specifically for Valora, it's controlling that and like deciding exactly which parts of these they should see and which parts they shouldn't see, and which parts of them do we kind of take care of for them in terms of like privacy and security, and And I think more broadly, things like decentralization, which a lot of users wouldn't know what the value of that is. So they wouldn't say, I wish this product was more decentralized. But, you know, having an opinion on that of like, it's important to do this so that we can actually achieve other features.
Yeah, for sure. I think we've had like a lot of conversations of just like, hey, like how much do you need to know in order to do this? And like, how do we make it simple and not intimidate you? But then also like, if you want to dive deeper, like how can we like provide kind of more access to like kind of deeper down the stack?
Yeah, I think there's something pretty interesting about that also, of just like all the features and all the options that, you know, what we're doing like offers, that what decentralization or cryptocurrency offers, and then also just trying to be diligent of like, oh, there's these 1,000 things we could do, which are the few that like, that actually resonate and provide end user value.
And what are some of the user behavior or requests that you find is surprising and that was requested by the end users? I mean, we've been doing a lot of testing internally as well. And what are the thing that you find it to be requested the most?
It's a good question. I mean, I think there's a lot of things that we hear. The things that don't come, something doesn't come immediately to mind as far as like, we're missing this and we wish we had this. It's more around like, there's interesting things that surface within the app, like things like buying Celo or buying gold, which it was called before, that like by its presence kind of like itself might be a confusing thing, but also its presence might also just like change how you feel, like what you think dollars is. And so like kind of controlling that and like trying to understand how like the introduction of certain features like actually change the comprehension of other features. So I think that's the most, I don't know if surprising is the word, but I feel like the most interesting part of it. And yeah, I guess we do like a pretty good job of doing pilots and getting out into the field, that we just have this like really great constant stream of like useful and also interesting, like thought-provoking ideas that come in.
Yeah, for sure. I think some things that stand out to me are just, I think things that like I wouldn't really think of, or just like people not knowing their like Play Store email account, of just like, you know, for beta testing, we would be like, hey, like, what's your email? And they're like, not sure like what I use. Like, it's just the one, or like, you know. And so I think that's like, it's just kind of things that aren't even inside like Valora that check your assumptions about like how people think about technology, or like someone we asked to, we were like, where would you keep your, you know, we call it account key, like people might refer to a seed phrase. They're like, oh yeah, I would just like type it into like my Chrome browser history so that I like have it in my Chrome browser history. And yeah, and so you just kind of have stuff like that. You're like, oh, I just wouldn't thought people would do that.
Yeah, there was also like a lot of interesting stuff around just like different ways people use phone numbers. Yeah, I think it can be common, at least in the US, to like just like associate a phone number with a person and to like assume that like you might have that phone number for the rest of your life, or at least you'll have it for a very long time. Whereas in other places, you know, multiple SIM cards can be more common, or turning through them can change a little bit more. And so all these behaviors, which are not necessarily Valora behaviors, but they're just like contextual situational frames that, you know, we have to design for, basically.
So we have one more question from Jack. You want to take that?
Yeah,
Connor?
Yeah, sure. Yeah, fiat on-ramping. Can a bank counter, how will people get fiat into the system? So yeah, that's another thing that I think Corey has spent a lot of time thinking through, is like, what are the, you know, different options, and what's the experience to go from cash to CUSD and Valora. Corey, do you want to talk a little bit about that kind of design exploration?
This is specifically for, sorry, I couldn't see the question.
It's just asking about how do you go from fiat to $. So like kind of like our on-ramps, cash in, cash out experience.
Yeah, so right now there's basically a way to like add or deposit or withdraw. And so we kind of use like a network of partners, and there's a option in the app to basically cash in through these partners, and you can essentially enter how much you would like to add, and then we'll give you sort of like basically the different rates that different folks are offering for that.
Yeah, so like MoonPay is one. So there's basically, right, you can always go buy some Celo on, I think one of the early things for us is like, CUSD was just listed, which is exciting, but when we first launched the work, it was kind of like getting Celo, the native asset, listed on exchanges. But there was no way to like buy CUSD anywhere. And so kind of internally, the team, a lot of the behavior was like, go to exchange, buy some Celo, send it to your Valora wallet address, and then use the like in-app like exchange to exchange Celo for CUSD. And so that was kind of this pretty cool, like, I don't think that necessarily we thought that like how important that would be in like the early days, but it was just like, yeah, that's like basically the on-ramp for everyone. Was like, for me, it was like ETH to like an exchange, get some Celo from the ETH, like Celo to Valora, Valora to CUSD is kind of like a little bit of a process, and I think we're working to make that easier. But yeah, so I think there's the exchange route. There's like places like MoonPay that you can just use your credit card to buy directly from them, and they'll kind of send it. And I think that especially with such a global focus, there's like our expectation, like Corey said, is that there's going to be like different networks in different places and different geos, and so that we've kind of like have the like designed in a way to support as we grow the network and grow the ecosystem, like to support multiple different ways. Any other audience questions, comments?
No, we don't have any more questions, and our time is out. So thank you all for joining, and thank you, Corey and Connor, especially giving this talk. And thank you to audiences for joining the talk today. So have a good, oh, there's one more question. Oh, thanks, guys. Yes.
Oh, thanks from Jack.
Yes.
No problem, Jack.
Thank you, Francis, for joining. All right, bye, guys.
Bye.
Cheers.
See ya.
Connor.
Yeah.